Today we'll look at factoring polynomials when a is greater than 1. We're going to study the British method. Now we'll go through an example of this first. We have the directions written right here, so let's follow along through this sample. It says multiply the x term with the constant term. Okay, well that's looking at ax squared and our c term. So 2x squared times 12 are going to give us 24x squared. All right, the next step says split 24x squared into two terms that add to 11x. Well, that 11x, remember, came from our b value. So we want to know the two terms that will give us 11. This has been done for us. We'll look at this further later and in terms of finding the whole table and finding which factor pairs work. But for now, we know that it's 8x and 3x. Okay, we bring down the original 2x squared and the 12, and we've split the 11x into 8x and 3x. The next step is group the first two terms and the second two terms and use the GCF. Sometimes this is also called factor by grouping because we are taking out the greatest common factor. So in 2x squared plus 8x, our greatest common factor is 2x. And when we divide both of these terms by 2x, we end up with x plus 4. In the second two terms, we have 3x plus 12. The greatest common factor here would be 3. When we take that out and divide by 3 in each of these terms, we're left with x plus 4. Now what's great about this is that the x plus 4 and the x plus 4 here are the same. So we can pull that out to be our first binomial factor. The second binomial factor comes from the two GCF values that we pulled out earlier, 2x plus 3. Now, if you're still a little confused, that's okay. Let's look at another example. Factor 6x squared minus 7x minus 20. Well, we'll start by multiplying our x squared value with our constant value, and we'll end up with negative 120x squared. Now we've got to find the factors of negative 120x squared. Negative 120 is a big number to find the factors of. I've already done this for you in a table, but we'll look later in a different video about how to use Desmos to help us find those table values easier. All right, so values that are going to give us negative 7x. Well, if you look at the table, I actually didn't complete the table because notice if you have 1x and negative 120x, another pair of values would also be negative 1x and positive 120x. But luckily, in this table, we have the two values that are going to add up to negative 7x. Those are 8x and negative 15x. All right, so let's split those up. Remember, we bring down our 6x squared and we bring down our negative 20. And we're going to plug the negative 15x and the 8x into our equation in place of the negative 7x. So the next step is to group our terms, group our first two terms and group our second two terms. Now we'll find the GCF of each of these pairs of terms. In the first one, 6x squared minus 15x will give us a GCF of 3x. What's left when we divide each term by 3x is 2x minus 5. In the second pair of terms, we have 8x minus 20, and the GCF here is 4. So what's left over when we divide out the 4 will be 2x minus 5. Again, these two values are the same in our parentheses. Our binomial values are the same, so we know that'll be one of our binomials. We can see 2x minus 5 and 2x minus 5 end up being in the solution. Remember, our second binomial term comes from the GCF, 3x and 4. Now, you may be wondering, well, in our factor pair in our table, 8x and negative 15 were the pair, but then I reversed the order and put them in as negative 15x and 8x. I wonder if that matters. Let's look at this example again, but we'll switch the order. Okay, factor 6x squared minus 7x minus 20. We have our multiple, negative 120x squared. We have our table of values, And we'll bring down the values this time, but switching the 8x and the minus 15x. Well, in this case, we can still do the problem. The GCF will just be different for each of the factor pairs. In the first pair, our GCF will be 2x. And what's left when we divide out 2x is 3x plus 4. In the second pair, this is actually a really good thing to look at. We have a negative 15x and a negative 20. So when we take out the GCF, we always want to try and take out the negative if we can. So in this case, our GCF is not just 5, but it is negative 5. So what's left again when we divide out the negative 5 is 3x plus 4. Our binomials are the same. So we'll use that binomial in our solution. 3x plus 4 comes down as part of our solution, and then we take the GCFs of both of these and make them our second binomial, 2x minus 5. If you remember from the last time we tried this, we got the same solution, 3x plus 4 and 2x minus 5. However, the last time we wrote it as 2x minus 5 and 3x plus 4. The order won't matter because these factor pairs, these binomial factor pairs, are still just being multiplied. And remember that multiplication is commutative, so the order doesn't matter.